All right, let's do this Unit 2 test review. You do have a vocab bank over here off to the left. Okay, cool. Sorry about that. So we have again, a vocabulary bank. So looking at number 1, as you can see, we have the transversal. These two angles are on different sides of the transversal, so that's called alternate. And then you can see that they're in between the parallel lines, so that's interior. Remember, alternates are congruent. Okay, alternate interior and alternate exterior. All right, so that was my transversal. All right, on this one, my transversal is here. So you can see that these are on the same side, but the question is, are they both in, both out, or one in, one out? So both of these angles are in between the parallel lines, so that's the same side interior. And remember the S rule, same sides are supplementary. All right, now check this out. Here's my transversal. These two angles are right next to each other and they make a straight line. This was from Unit 1. When you have two angles right next to each other that make a straight line, okay, if you look at your answer choices, these are a linear pair. Which is answer A. Alternate interior was E. Same side interior is G. Now, a linear pair, if it makes a straight line of 180 degrees, that's definitely supplementary. All right, and then over here, number 4, here's my T transversal. Now, these look like they're on the same side, but before you write the word same side, you got to think about, is it both in, both out, or one in, one out? So here we go. We got one out, one in. So if one's in, one's out on the same side, you want to think, hey, they're both in the same position in the top left of the intersection. That's called corresponding. Hold on. Corresponding. And the C rule, corresponding, are congruent. All right. Number 5, these two angles are on different sides of the transversal, so it's alternate. And they're outside the parallel line, so that's called exterior. Alternate exterior, which is letter D. And remember, alternates are congruent. That's the rule. Alternates are congruent, just like number 1 and number 5. Okay. Now this one's kind of weird. What if you have two angles on the same intersection across from each other? You got to remember this from Unit 1. These are called vertical angles. Okay. And vertical angles that are across from each other match, they are congruent. All right, last one, number 7. We got this transversal. The angles are on the same side of the transversal, but they are outside the parallel lines. That would be same side exterior angles. And remember, same side exterior, the S rule, they are supplementary. Cool. All right. right, next part is number 8. All right, so let's think about this. I got my transversal. These two angles, this one's obtuse, this one's acute. Remember, one's obtuse looking, one's acute looking. If they don't match, you can already tell they're supplementary. But the name of the angle pair is they are same side. They're outside the parallel lines, so they are exterior. So again, S rule, supplementary. So remember, for supplementary, you do not set them equal. You add them up. So 4x plus 10 plus 70 equals 180. Okay. Now I'm going to solve it by hand, but I'm going to remind you of how to do the end solve method too. Cool. So on this side, there's two constant numbers that can be combined, combining like terms. 10 plus 70 is 80. Bring down 4x. Get rid of this loner 80 by subtracting 80. 180 minus 80 is 100. And then you divide by 4, the coefficient, to get x equals 25. Now, let's leave that there. Remember, in your calculator, if you press on, new document, don't save, number 1, you can use menu 3, 1. You just have to remember to use comma x when you type it in, okay? So menu 3, 1. I know I used parentheses in the original equation, but I can just do 4x plus 10 plus 70 equals 180. I cannot forget the comma x. Okay. You can end solve it to get the same answer 25. Okay. Please have a method, whether you solve it by hand or end solve. Now it says ACB. Now if I go over here, ACB, whoops, ACB over here is 4x plus 10, right? Well, I know x is 25, so I'm going to replace x with 25. 4 times 25 is 100. Add 10, I get 110. All right. Again, you could just type in 4 times 25 plus 10 in your calculator and get the answer as well. Okay. Now, number 9, if this angle is obtuse, this angle is obtuse looking. Now, I know this number doesn't match if it says 75, but the main thing is they visually match, right? So they're on different sides of the transversal, so they're alternate, and they're in between the parallels, so they're alternate interior. And the rule, alternates are congruent, and you can tell they match. They're the same classification. So if they're congruent, that's when you set them equal. So 3y plus 60 equals 75. You can end solve it, menu 3-1, or solve it by hand. So subtract 60 to get 15, and then to get rid of that 3, we need to divide by 3. And you get y equals 5. So y equals 5. Now we're looking for DCF right here, D to C to F. So angle DCF equals 3y plus 60. You you're just going to plug in 5 for y, place it with parentheses 5. 3 times 5 is 15, and then you get 75 when you add them together. All right. Number 10. So on this one, again, I have an acute angle, and then I have an obtuse angle. They don't match, so I can already tell they're supplementary. But I can also tell because of the angle name. This is my transversal. They're on the same side and in between the parallels. So that's same side interior. Side interior. And remember the S rule, same sides are supplementary. That means add up to 180. Okay, so my equation, 2x plus 20 plus 150 equals 180. Combine like terms. 20 plus 150 is 170. Get rid of the loner, 170. X equals 10. Divide by 2. And x equals 5. For A, C, B. Now this is weird. A, C, B is right here. This is obtuse, and it should match the other obtuse angle, right? Angle ACB is congruent to angle CFE. Again, we may not have this angle right here, but we know it has to be the same as 150 because they're corresponding angles. So it equals 150 degrees. Another way you know that is look at the zigzag. 150, 150, 150, right? Cool. All right, given the equation, solve for the x-intercept. Now, if you don't remember this from algebra 1, it tells you what to do. Plug in 0 for y. So 2x plus 0, 12. That's gone. So now I just divide by 2 and get -6. What about y-intercept algebraically? Plug in 0 for x. So -7 times 0 plus y equals 9. -7 times 0 cancels out, so it's just y equals 9. So again, for intercepts, you plug in 0 for the other variable. Okay, 13. Let's plot these points, 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. And then 1, 8. 1, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, it's off the grid there. But if we count slope, which is rise over run, right? We go down 1, 2, 3. Down 3 is -3. And then we always run to the right 2. -3 over 2. Okay, on the next one, -2, 3, -2, 1, 2, 3, 6, -4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Okay. Now between these two lines, at points, I mean, we can just rise over run. So rise 1, 2, 3, 4, 5, 6, 7. Down 7 is -7. 1, 2, 3, 4, 5, 6, 7, 8. Over 8. So -7 over 8. Okay. Now on these, you can use the slope formula, y2 minus y1, y2 minus y1. Over x2 minus x1. -6 over -4. Again, your calculator can help you do this and reduce it to the most reduced fraction, 3 over 2. Again, y2 minus y1, negative 3 minus 5 over x2 minus x1. Careful when you're subtracting a negative number. You got to write minus sign, then negative sign. Or you can turn the minus a negative into a plus sign. Either way, negative 3 minus 5 is negative 8. 6 plus 1 is 7. That does not reduce. Let's look at this. Sketch the graph of the following equation. So we want to, again, mx plus b, you plot the b first at positive 2. And then you rise over run. Negative 3 over 4 is down 3 over 4. Okay? And you want to make yourself a nice line through those. Nicer than mine. 21, first we want to solve for y. So if I move over that x, minus 2x, remember it goes in front of the b. So y equals negative 2x minus 5. And you want to put that over 1. And again, we grab the b first, the negative 5. And then our slope is negative 2 over 1, which is down 2 over 1. You could also think of it the other way around, up 2, left 1. Okay? But either way, you should get this line. All right. When you have parallel lines, what do you do to the slope? You keep the slope the same, but you change the y-intercept into whatever you want. Okay? That's for parallel. Same exact slope. But perpendicular, which again looks like this with a right angle, right? Then you what the slope? Okay, you change the slope and the sign. It's not change, but sorry, flip the slope and change the sign. Okay, opposite reciprocal is what we say in math. The positive slash negative sign changes, and then you flip it. So for example, negative 1 over 2 perpendicular will be positive 2 over 1, right? That's just an example. That is a different class. Grab that and move it over here, sorry. Oh, and then this too, whoops. Okay, whoops, let me back up. You know what? I accidentally forgot to do 17. Okay, here, 17. Find the slope from the points. Again, we're going to do y2 minus y1 over x2 minus x1. So I get negative 12 over 5. That does not reduce. You can plug it into your calculator to find that out. Okay, we need to solve for y on these and then find the slope of the y-intercept. So to solve for y, we move over the x first. Minus x, put it in front. 3y equals minus x plus 6. Remember, you can put a 1 there for minus x, minus 1x. Divide by 3, and I get y equals negative 1 over 3x, and then 6 over 3 is 2. So my slope is negative 1 over 3. My y-intercept is 2. Okay, because that's my m and my b. Same thing on 19, we get rid of that x, minus 5x, minus 5x. This goes out in front of the 8. So 2y equals minus 5x plus 8. Divide by 2. Y equals negative 5 over 2x plus 4. M is my slope, B is my y-intercept. All right. Now, this was like yesterday's warm-up. For a parallel equation, you keep the slope. So y equals -5/6x, but you change that -3 to something else, okay? This is what changed. Now for perpendicular, let's take that -5/6. We change the sign, negative becomes positive. 5/6 flips to make 6/5. So this is my new m for my perpendicular slope. So let's do that. Y equals 6/5 x. And we can keep the -3 from the beginning. We just have to make sure that slope has two changes. Same thing with 25. This is 4/1, right? So when I write the equation, I can write it as 4x. I got to change for parallel, change the +7 to something else. Doesn't matter. But if I have 4/1, perpendicular slope, I'm going to change the positive to a negative. 4/1 flips to make 1/4. So this is my new m. So y equals -1/4 x. And then we can keep that original y-intercept of +7. Okay. Cool. So you want to write an equation with a y-intercept of 5, that's my b, and my slope of -2, that's my m. Easy. mx plus b. -2x plus 5. All right, are these parallel or perpendicular? +4/7, -7/4, perpendicular. Hold on. Because it's opposite reciprocal slope. Okay, 2/3, 2/3, same slope, that's parallel. Okay, I'm gonna solve this over here. Minus x, divide by -5. Get 1/5 x minus 2. And then for this one, sorry. Hold on. I'm doing something crazy here. I need to divide by 10, that's what it is. 5x plus 3. All right, now, same slope, parallel. Okay, let's solve this one. I know this is tedious. Dividing by -3, I get y equals 2x minus 6 minus 7x on this side. 14y equals -7x plus 28. Divide by 14, and I get y equals -1/2 x plus 2. -1/2 and +2/1 are opposite reciprocals. That's perpendicular. Okay. All that. And then last but not least, find the equation of the line parallel to the given equation, and that contains this point. So point 2, 3 goes right here. it's parallel, the slope is going to be 2 over 1. So 2 over 1, 2 over 1, 2 over 1. And if you go backwards, down 2, left 1, down 2, left 1. Okay, you get the idea. So let's make a straight line through this. Cool. And then I can see right here my b is -2. Sorry, -1. So y equals 2x minus 1. All right, and that's your review.